All right, so welcome back to the Cloud Forest tutorials. Today we're going to be talking about working through doing some community detection, and then we will go through how to visualize those results and sort of interplay them with some other results within Cloud Forest. So if you've been following along with the tutorials so far, previously, we utilized the Cypress REST API to infer trees. And after that, we then used those trees to perform an NLDR and to visualize the tree space of those trees using Cloud Forest. And so now sort of the next logical step is using those trees and trying to detect sort of intrinsic structure within that set of trees that might not be totally obvious to the naked eye. So as you can see here, we have a set of trees that I've imported here. So this is a set of trees sampled from the posterior distribution in a Bayesian analysis for 4 different mitochondrial genes. So we have sort of 4 different hypotheses here. And as you can see, so what we did first, taking these trees, as we did in the previous tutorials, we came over to the Cloud Forest tab to Treescaper trees. And then the first thing we did was compute a distance matrix with those trees. And so then after computing that distance matrix, which you can see we have right here, we use that distance matrix in an NLDR computation. And in this case, you can do 2 or 3 dimensions, just depending on what you prefer. In this instance, we did a 2-dimensional NLDR. And so that brings us to right now. So the first thing you need to compute, to do community detection on our distance matrix and on our set of trees, is we have to compute an affinity matrix. So essentially what this does, and again, we can come here in the Cloud Forest tab and scroll down to Treescaper Affinity. And so what this does is it is essentially sort of taking the reciprocal of the distances in our tree-to-tree distances. And so the effect of that is that great distances have very low affinities, and low distances have very high affinities. So it kind of inverts the scale a little bit in our analyses. So we have 2 different types of affinities we can compute. We've seen sort of more stable results so far using the reciprocal affinity type, but as always, feel free to kind of play around and use both and see how the results change for you. So we select the reciprocal affinity type here. And if we click execute, then we will then begin computing a affinity matrix. And so we'll give that just a second to finish running. Okay, so coming back here now, our affinity matrix has finished running. And so now that we've computed that affinity matrix, we can come over to the Treescaper Community Detection tab. So you'll see that the input file here is going to be that affinity matrix that we just computed. We now have a set of models that we can select from. Again, feel free to experiment with the different models, compare results. All of these models sort of perform groupings within the community detection in slightly different ways. So definitely kind of compare. Right now, we're going to use the configuration null model. Just we've seen pretty good results with that in the past, so we'll just kind of use that as a starting point here. And to begin, we'll also use automatic tuning. So we'll let the algorithm sort of automatically tune itself with all the various model parameters to try to find the best results. So with all that selected, we can go ahead and click execute, and we will send our job off, and we'll wait for that to finish. Okay, so it's been a few minutes while we let that community detection run, and now we're back. So you can see on the right here, our community detection results have finished. So now we can take a look at what those results look like. So if we come over to the Create Visualization tab, scroll down to Cloud Forest, Create Visualization, And we can also go ahead and enter the full screen view just so we can get a full view of what's happening here. So for the visualization, we're going to go down to community detection. And now you can see here we have sort of a list of options for our input files for this, this visualization. So to start, we've got the community detection plateaus, the plateau file, which we just computed, and we have the results file we just computed. And now for the NLDR coordinates file, we're going to select the NLDR coordinate file that we previously computed. And we come over here and click Run and scroll down a bit. And so you can see on the left side of the screen here, that is where our community detection results are. And then on the right side of the screen is where we have the NLDR. So to start out, we're not visualizing any groupings yet. But you can see in this example, kind of with the naked eye, you can definitely pick out kind of the natural groupings of those 7 different gene trees. And so now using community detection, we can start scrolling through our results. And what you really want to be looking for here is sort of the red line here. And what we're going to be looking for is sort of plateaus on this red line. So this is the number of community labels here. And so what a plateau kind of symbolizes is as we test these different lambda values, this parameter within our model, as we test different lambda values, we're going to start to see changes in the community structuring that the algorithm picks up. And so there's a lot of randomness kind of within that as we test different values. But if we have sort of plateaus where ranges of different lambda values all give the same result, then that kind of indicates a more stable community structure. So we can start here, we can start dragging our slider, and as we drag it, you'll start to notice the NLDR visualization on the right side of the screen starts to dynamically color the points, which are our trees, according to which group the algorithm found they fell in. So we can start to see those groups here. We'll start to scroll, and as we start to hit those plateaus, we can see a little bit of a stable grouping here. And then at the largest plateau here, we have what looks like sort of that stable, really stable for community structure. So again, this was a data set, trees sampled from the posterior of 4 different genes. And as you can see, there's definitely some inherent structure within this tree space. And so the community detection has obviously picked up on that. And as you continue scrolling here, you can see kind of how the groupings change a little bit. And you can start to see sort of that randomness we were talking about as we continue on. So that was using the automatic tuning available within the community detection algorithms. But if you wanted to get sort of you can kind of view this as sort of a kind of a rough overview of what the community structure looks like. So now what we can do is we can sort of identify this range here where it looks like interesting things are happening. So, you know, potentially starting around 0.45 and going to around maybe 0.9. If we specifically input those values, we can potentially get a closer look at what might be happening in that range. So the way we do that is we come back into CloudForest and go back to our community detection. Again, we're going to be using the same affinity matrix that we used previously. We'll stick with the configuration null model. And so now we'll choose manual tuning. And so using manual detuning, we'll be able to manipulate which specific lambda values the model tests. So in this instance, when we're looking at affinity matrices and NLDRs, we're going to use a fixed lambda negative. And so in this case, the negative lambda doesn't matter a ton because values in this matrix can only be positive. So this value doesn't matter a whole lot. This LPS parameter here, That's going to be our lambda positive start value. So as we talked about a second ago, we want to kind of zero in on that range we identified. So for our lambda positive start, we can input 0.45. For our lambda positive end, which is this parameter right here, we'll go to about 0.9. And this value here tells the algorithm how big of steps to take in lambda values. So here we want to do a fairly kind of fine search. So what we can do is maybe 0.001, just so we get a good view of the variation within that range. Once we have all those numbers input, we come back down to execute and send that off. Okay, so coming back now, we've let the algorithm run. It takes a few minutes for the community detection algorithm to do its magic. And we come back now and we've got the results of our manual community detection. So again, we'll go back to our visualization tab, scroll down to the CloudForest visualizations, create visualization, go to our full screen, and then we will go down to the community detection again, and now we'll have the option to visualize our manual community detection results. Again, we'll select our same NLDR, go down, click on Run, and now we get a sort of, you can see kind of the difference between the two analyses that we've done. So last time it was kind of a more rough search, and now we have sort of a much better view of all the different kind of variation and plateaus within the lambda values that we tested. So let's scroll through and we'll see how the sort of groupings change. We come to our first plateau here, where we have a bit of variation. It's sort of identifying a bit of variation there. Another plateau here where we get a pretty good 4 community structure there. Another one here, it looks like. And so again, you can really see sort of a really good view of those plateaus that we're looking for, that kind of stable signal. And as we continue scrolling through, we get a bit more of the same, a really nice 4 community structure there. And so yeah, that's the sort of the visualization of our manual results there. So again, this represents obviously a scenario where we have a pretty clear structure within our tree space here. We've also seen some analyses where there's a bit more cryptic structuring that's not as visible with the naked eye, and Treescaper and CloudForest are able to recover some really interesting sort of biological variation between different parts of data sets with a lot of biological relevancy. So definitely try this out with some of your data, see kind of what kind of structure you can detect. And as always, definitely stay tuned for some more CloudForest tutorials where we walk through some more cool parts of the platform. As always, this tutorial is also available in a written form on the Treescaper website. So definitely follow along there, or check here if you need a bit more detail. And yeah, stay tuned with the CloudForest team as we keep bringing forward these really cool visualizations that hopefully you can use to get at some really interesting facets of your data.